Howdy, howdy. This is Mr. Potter. In our previous lesson, we were talking about how to flood fill an area with a particular symbol. And the idea was that I would recursively look above, below, to the left, and to the right to see if I could fill in that area. And if I could fill in that area, I would fill in that one character position, and then again check above, below, to the left, and to the right of that position, and try and fill up the map up to whatever border I happen to see. Basically, a border was anything that wasn't a space. I want to take that one step further, and I want to talk about how we would actually go about traversing a maze. So what I've got here is I've got four different mazes here. I've got this simple maze where I've got a start, I've got a finish, and there is a path from the start to the finish. I would just go from the start position up one, and then to the right two. So up two to the right two, and that takes me to my finish line. I've got this basic maze where it's a little bit larger, and there's some more turns in here, but there's still just one path to it. And then I've got a third maze that I've made, which is the same maze, but a little bit trickier. So there's some nooks and crannies here. I can go up and down and get caught in this dead end. There's another long dead end here. There's another dead end going up here. There's a dead end right before we make the final line to the finish. But there is a path. I could go to the left, up, left, and then keep going up, move over, down, over, and down to the finish line. And then I've got this unsolvable maze, which is the exact same maze that we have here, just with this path blocked off. So you can't actually solve it. And we're going to do the same idea. We want to try and be able to traverse this maze in such a way that we can indicate what the path is using the recursion methods that we've talked about. So I've got a little bit of a class written here. I've got a char matrix called maze. I'm keeping track of the starting row and finish row and column. And then instead of reading in an array like we did before, we used an array literal because we knew exactly how big the United States was. It was 75 characters long and 20 rows tall. Because I don't know how long each file is going to be. Notice that some of these mazes are pretty small and some of these mazes are a little bit bigger. I'm actually going to use an array list because that dynamic memory that it's got, it can add as many strings as I see fit to give it. So what we're going to do is we're going to load this from a file. So because we're doing the file, again, I'm using the try catch that we talked about in a previous lesson. I'm still using the same scanner, but instead of using system.in as my input mechanism, I'm using a file object. And I need to make sure that I import those statements as I need it. I need to import array list, I need to import scanner, and I need to import file. So as long as there's something new to be had, then I'm reading in an entire line of text that's basically an entire row of this maze. So this would be the first row that I line up, the second row, and so forth. And then I'm adding it to this array list. And what I'm also doing is I'm keeping track of how long each of these lines are, because I don't know how big to make my character matrix until I've read in all the lines of code. I don't know how many rows to make, because the number of rows should match the size of this maze buffer, the number of strings that I've read in. And the number of columns that I should have should be whatever the longest row that I have is. So that's what I'm doing here, checking to see if the length is bigger than the number of columns we've got so far. Then let's go ahead and resize it. So I find the maximum number of columns. And I've got a catch here, just, if there's a problem with the file name, I mentioned there's a problem with the file name. And then I create my maze. This basically a char a matrix of num rows and num columns. And then I go through the list and basically add those elements to my list. So I'm going through a nested loop here, and then up through here, I just basically fill it in. Now I'm keeping track. If I find the start of my maze, then I'm going to keep track of the start row and the start column, because this is where I'm going to start my recursive search. And if I find the finish of a maze, then I'm going to keep track of the finish row and the finish column, because this is going to be my base case that I'm trying to get to for my recursion. And then just a simple statement that says the maze is loaded. And the print maze is exactly the same as we did before for the print map, using for each loops for each row of the maze, for each column in the row, and then printing out that result. And then here's what our maze looks like. It's very straightforward, very, very simple. I'm going to call on some method called initialize maze, which loads the particular file. And I've got it set up where the file name is a string literal as a parameter. So I can change this from simple maze to basic maze to hard maze to unsolvable maze. And then I call in the print maze. And then what I'm doing here is, instead of my solve maze being a void, like flood fill was a void in the previous program. I actually want this to be a Boolean method. And the idea is that because it's a Boolean method, I will know whether or not the maze has been solved. So I can actually return if I get a true result starting at the starting row and starting column. Then I'll go ahead and print the maze, and this printed maze should have its solution printed in it. Otherwise, I'm just going to send a simple message here that says it's unsolvable. So let's go ahead and talk about how to write this. So I've got public, static, Boolean, and I'm going to call this solve maze. Where I'm going to have an int R and an int C. And just as I did before, the first thing I want to do is I want to check for boundaries. So I need to make sure that I'm not out of bounds, because checking the row above or the row below or the column to the left or the column to the right of a given position might force me out of the bounds of the array. And of course, I'm not going to be able to address anything if I'm outside of the bounds of the array, because I can't tell what's that position -1, 0, or what's that position 30, 40 if I don't have 30 rows or 40 columns. So I'm going to see if my R is less than 0, or my column is less than 0, or my row is greater than or equal to maze dot size, or length, I mean, or my column is greater than or equal to maze sub 0 dot length. And I'm using maze dot 0 because I've set this up to be a rectangular matrix. So the number of columns is the same for each row. But I know that R has to be in bounds before I check this. I don't want to make this maze sub R dot length, because if R is out of bounds, it's not going to short circuit and check this out. It's going to keep going through, and I'm going to get an index out of bounds exception. Making this a 0 ensures that I don't have an index out of bounds exception. But if I'm out of bounds, then this is not a solution. So I'm going to return false. And so that takes care of my boundaries, but notice that also is going to tell me, hey, if I ever reach this condition, it's not going to be part of my solution, so I'm returning false. And I also need to think of my base case, which is, did I reach the finish? And if I reach the finish, I know that because the maze at position R C is going to be equal to the capital letter F. And if that's true, then return true, because I have done it. So now what I need to do is I need to see, okay, I know if I'm not in the if I'm within the boundaries of the maze, but I have not hit the finish line. If I'm at this point, I need to check if I'm at a valid point. So there are two different types of valid points. I can see if maze sub R sub C is a space, but keep in mind that I'm starting at an S, so I really need to check to see if I'm at an S as well. So if I'm not at a space, or I'm not at an S, then I've hit a wall. This is not a valid solution. Not a valid solution. So I'm going to return false. So if I've reached this part of my code, I must be on a path. May be the right path. But the thing that I'm going to have to be careful of is that if I don't do something at this point, then when I do the recursive call to search the row above me, and that recursive call does a recursive call to check the row below me, I can end up in an infinite loop. And when I do that, the Java will actually give me a stack overflow error if I go too deep into the stack, so deep that I end up using all of the memory for this virtual machine. So what I'm going to do is I'm going to leave a breadcrumb. So what I'm going to do is I'm going to say maze sub R sub C is equal to A. In other words, I've already accessed this position. So in the act of making recursive calls, if I ever come back on this position, I know, wait a minute, I've already been here. I don't want to check this spot again. So we're keeping track of that. So maze sub R sub C gets A. And then I want to do my recursive calls. So what I need to do is I need to check above me, below me, to the left of me, and to the right of me. So I'm going to check above. So if maze sub R plus 1, or excuse me, R minus 1 sub C and I want to check to see if that is a valid position. So I actually want to solve maze for that row minus 1 and C. And if I get a true out of that statement, then I must have successfully hit finish at some point, because the recursive calls will return to me a true, and I want to pass that true on to whoever called me. So I'm going to do two things here. The first thing that I'm going to do is I'm going to say, hey, I'm part of the solution. So maze sub r sub c is going to get a hashtag, and I'm going to return true. So in other words, if solve maze for the row above me gets to the finish line, that means this must be part of the solution, because this is part of the path to the cell above me. So I'm going to return true to whoever called me. And I'm going to do this exact same code, just with different rows and columns. So I've checked the row above me. I now want to check the row below me. So solve maze for r plus 1, C. And if that's true, then maze sub r sub c gets pound sign and return true. And then I want to check the columns to the left and right of me. So if solve maze sub r and c minus 1, then maze sub r sub c gets pound and return true. And then I want to check the position to the right of me. So if solve maze sub r c plus 1, then maze sub r sub c gets pound sign and return true. Now, if I reach this point, then I know that there is not a solution above me or below me or to the left of me or to the right of me. So I must not be part of the solution. And so at this point, I'm going to return false. So there is a lot of stuff going on here, because there's a lot of complicated action. So I want to go through here and kind of reiterate what we've done here. The first thing that I'm doing is I'm checking for boundaries. So I check to make sure that my row and my column are valid. If any of these values are not valid,